All right, good morning. Today we're going to get going on section 6.6, and the topic for today is going to be something called a geometric sequence. So in just a minute here I'll read through the definition with you and then we'll go through a bunch of examples. But I just want to let you know that anytime you need to pause the video to take notes to make sure you get something in your notebook, feel free. Like always, our tests are going to be open notebook. And so it'll be helpful if you get some definitions and examples down so when it comes time for the test, you know what you're up to. Okay? So we'll get started with what a geometric sequence is. We start with the definition here. A geometric sequence is a sequence in which you multiply by the same number to go from one term to the next. So the key word in the middle of this thing, you multiply by the same number to go from one term to the next. So as an example, if we start off with a 5 and we start multiplying by the same number, let's say we multiply by a 2, 5 times 2 gets you to 10. Then you multiply by the same number, 10 times 2 gets you 20. If you multiply by the same number, 20 times 2 is 40, and so on, right? And so when we continue that sequence, it becomes something called a geometric sequence because what we're doing is we're multiplying by the same number. It doesn't change. We're multiplying by the same number over and over and over. Okay? So let me just do another one for you just as an example. If we were to start with a 6 and ask you to go from one term to the next, if we asked you to multiply by, let's say, -2. All right, so 6 times -2 would be -12. But now because it's geometric, we have to multiply by the same number. So -12 times -2 is positive 24. Then when we multiply by -2 again, 24 times -2 is -48. And let's get one more in there anyway. Let's multiply by -2 again. -48 times -2 is positive 96. Okay, so those are both examples of geometric sequences, all right? Also, please remember that the dots on the end of one of these folks, so let me choose a highlighter here. That didn't work at all. Let me choose a highlighter. The dots on the end, remember those dots, they're called an ellipsis, and that just reminds you that the sequence just goes on forever. You could continue to multiply by 2, 2, 2, 2, or -2, -2, -2, -2. Okay? So that's a geometric sequence. Now, when you actually start with the geometric sequence, and let me write out several examples, so it'll just take a minute. 2, 8, 32, 128, and so on. 4, 20, 100, 500, and so on. 3, -18, 108, -648, and so on. And I've got room for one more here. 24, 12, 6, 3, and so on. These are all examples of geometric sequences, and you'll see that as we go through some of the examples here. All right, but one of the things we're going to ask you to do is we're going to show you something that's a geometric sequence, and we're going to ask you to find the number that we're multiplying by over and over and over. And we give that number a special name. It's called the common ratio. It's called the common ratio. And we usually use the lowercase letter r to designate that. So what I might do in a series of problems like this is give you a geometric sequence and say, what's the common ratio? Okay? Now to find that common ratio, to find that multiplying number, sometimes it's a little bit easier, sometimes it's a little bit harder, but in general, here's what you do. You take any of the terms in the sequence, as an example on this first one, my numbers are jumping around here, there we go. As an example in this first one, we take any one of the numbers and we divide by the number that comes before it. take any one of the numbers and divide by the one that comes before it. So as an example, if you take 32 and divide by 8, you get 32 divided by 8, which is 4, and that's going to be the common ratio. Now, I happen to choose 32, but if you would have selected 128 and divided by 32, you would have gotten 4. If you would have selected 8 and divided by the one in front, you would have gotten 4. So it doesn't matter. Pick any of the terms and divide by the one in front of it. So on my second example, take 500 divided by 100, or 100 divided by 20, or 20 divided by 4. No matter which one you pick, divide by the one that comes before it, and the common ratio would be 5. On the third example, take any one you want, 108 divided by negative 18, negative 18 divided by 3, no matter which one you grab, the common ratio would be 6. And then finally on this fourth example, take 3 divided by 6, or 6 divided by 12, or 12 divided by 24. No matter which one you grab, what you'll get as a result is 1/2 or 0.5. And I don't care if you use the decimal or the fraction. Okay? So given your own sequence, given a sequence, you need to be able to find the common ratio. And you'll see why in a couple of minutes. Okay? Alrighty. Now, remembering sequences from earlier this year when we had talked about arithmetic, and just a quick reminder, this is old, right? Or if you prefer, this is a review. Sequences that were arithmetic, right? You didn't have to multiply by the same number to go from one term to the next. What you had to do with arithmetic is add the same number over and over to get from one term to the next. So again, this is old. An arithmetic sequence would have been something like 7, 13, 19, 25, 31, and so on. Please notice you have to add the same number, add the same number, add the same number, add the same number to get from one term to the next. So when we added the same number every single time, then the sequence was called arithmetic. It was called arithmetic. Okay? So that was just a quick refresher. There'll be a couple problems on your assignment that'll ask you to tell the difference between arithmetic and geometric. Arithmetic, we're adding the same number over and over. In geometric, we're multiplying by the same number over and over. Okay? Now, if we were to look at the graphs of one of these, it's going to become apparent why we're doing this right now. The table of values that we get for a geometric sequence could look something like this. 1, 2, 3, 4 for the x's, and something like 2, 8, 32, 128 for the y's. Okay? So this is just an example of a table for a geometric sequence, and you can kind of see this. I'll just do this quick. If you take a look at any one of these terms, and if you divide by the one that comes before it, divide by the one that comes before it, divide by the one that comes before it, you always get the same value. You get 4. So therefore, it's geometric. But the reason I bring this up is so that if we were to graph this, 1, 2, 2, 8, 3, and 32, of course, goes off my picture, but I think you'll get the feel for this, and 4 and 128. You're going to see that the type of graph we get is the one that we've been working with this whole chapter. It's going to be an exponential growth picture. And that means you also know it'll flatten out, flatten out, flatten out, flatten out to the left. Okay? So anything that forms a geometric sequence also is exponential. And that's why we're doing it when we are. Obviously, we've been talking about exponential equations and exponents this entire chapter. Okay? Alrighty. Now, we have a formula for a geometric sequence. And I'm going to need to make sure you get this in your notebook and then put a big box around it because we'll use it on quite a few problems, right? And it looks like the following. A sub n is equal to a sub 1 times r raised to the n minus 1 power. So this is something we're going to use several times, so write that in your notebook and then put a box around it. And then I'll remind you what each of these pieces are, very similar to the arithmetic sequences that we had done a couple months ago. A sub n represents what's called the nth term. So one of the questions I'm going to ask you in just a little while is something like, what's the 10th term of one of these geometric sequences? So n is whatever term we're looking for. A sub 1 is the very first term in the sequence. And as you just saw a couple minutes ago, r is going to be the common ratio, right? And then finally the exponent there, let me highlight it just so it's obvious. And then the exponent is always going to be one smaller than whatever term number we're looking for. All right, so the exponent, let me choose red here. The exponent is always going to be one smaller than that number. So if we're looking for the 10th term, the exponent will be 9. If we're looking for the 43rd term, the exponent will be 42. It's always going to be one smaller. It's always going to be one smaller. Okay? Alrighty. So again, make sure you pause this if you need to so that you can get that formula down into your notebook. Okay? And then here's a couple of numerical examples. And these are the types of things I'll place on your test. Okay? So here's a couple of examples on how we use that formula. I'm going to give you one of the sequences from above. So it's the same one you have written down above. Okay? And what we're going to do is we're going to ask you a question like the following. Given this geometric sequence, what's the 10th term of that sequence? All right? And please notice that what we're doing is we're multiplying by the same number over and over to get from one of these terms to the next. Please notice we're multiplying by 4, multiplying by 4, multiplying by 4. Okay? So you guys would have two choices. Since this is obviously the first term, this is the second term, this is the third term, this is the fourth term. One choice is just to continue to multiply by 4, multiply by 4, multiply by 4, multiply by 4, until you get to the 10th term. So you'd have to multiply by 4 6 more times. Okay, totally fine. But I'd like to show you how the formula gets you there very quickly. The formula, again, I'll put in a different color above, so just so it makes sure everyone remembers that the formula we just wrote down was a sub n equals a sub 1 times r raised to the n minus 1 power. So please notice how quickly you can get to the correct answer. A sub 1 is the first term. So the first term in our sequence is 2. Let me make sure I have the correct color there. So that's a 2, right? R is the common ratio. And you can see the common ratio of the number we're multiplying by over and over and over is 4. And then, as I just mentioned, the exponent is always going to be one smaller than the term that we're looking for. So since we're looking for the 10th term, the correct exponent we're going to use then is 9. All right, so all we need is the first term, 2, the common ratio, 4, and a number one smaller than the term we're looking for. We're looking for the 10th term, we use the 9th power. And then I just need you to remember your PEMDAS and remember that exponents come before multiplication. So we do the exponent first, so that means what's 4 to the 9th power, what's 4 to the 9th, and then we have to multiply that answer by 2. Now, of course, 4 to the 9th is pretty tough, so I'm going to use my calculator. 4 to the 9th power is 262,144. And then when I multiply that by the 2, doing the multiplication second, my 10th term then is going to be 524,288. And that would be then your 10th term. That would be the 10th term. Okay? All right. So I'm just going to do one or two more of those, kind of make sure you're all right on that. And then we'll call it a day here. You guys can turn the video off and go ahead and get started on the assignment. But here's two more examples. Again, going back up to the original examples I had first written down. Here's the next one. 3, negative 18, 108, negative 648. And this is the one we had done earlier. You just noticed that we'd have to multiply by negative 6, multiply by negative 6, multiply by negative 6 to get from one term to the next. Okay? And what I might ask you on a problem like this is, what's the 7th term of the sequence? So the formula again is the following: a sub n is equal to a sub 1 times r raised to the n minus 1 power. Okay? A sub 1 is the first term, and let me highlight that for everybody. The first term up above is 3, so that's the very first term is the 3. Then what we have to do is multiply by r, and the common ratio you can see is negative 6, so we fill in a negative 6 for r, and then we have to raise that to a power 1 smaller than the exponent. Remember, the exponent 1 smaller than the term number. So if we're looking for the 7th term, we have to raise that then to the 6th power. And again, we always do the exponent first, then the multiplication. So what I need is negative 6 to the 6th, which is 46,656. Then multiply that by 3. And what we get as a result for the 7th term is 139,968. So the 7th term would be that number. Okay? And finally, one last example for today. And that's going to be the following. 24, 12, 6, 3, and so on. And again, this is the one from above. So this is one where we were multiplying by 0.5 to get from one term to the next, and so on. Okay? So what I might ask you to do on a problem like this is find the 14th term. Find the 14th term. Again, our formula is that the nth term is going to be equal to the first term times the common ratio raised to a power 1 smaller than the term number. Okay, so here we go again. The first term, written right in front of us, is 24. The r is the number that we're multiplying by over and over and over. So here that's a 0.5. And then finally, the exponent is always 1 smaller than the term number. So since I'm looking for the 14th term, the exponent then has to be 13. And once again, we do the exponent first, and then we do the multiplication, second. So 0.5 raised to the 13th power is, I'm going to use parentheses so you guys can see the decimal point, 0.000122 rounded off. And then when we multiply that by 24, we get approximately, we're doing a little bit of rounding here, but we get approximately 0.002929. And if anybody's interested, if I were to change that to a fraction using my calculator, it actually turns out to be right on the nose, 3 over 1,024. So either one of those is fine. You can let your calculator make that switch for you, right? But we have the approximate decimal or the exact fraction. Okay, alrighty. So that gets you a really decent start on section 6. I'll be back tomorrow, and when I get back tomorrow, we'll do a few more examples. We'll do some work out of your book, and then we're going to do a really kind of fun problem, I think. Together, we're going to work on number 40 out of your assignment. So we're going to kind of talk through that one together. Okay? So hopefully you're having a good day. Video is going to be done here in just a minute. Feel free to shut it off. Open up your book. Go ahead and get started on the assignment. Do the best you can. Help each other out a little bit. All right? And we'll talk to you tomorrow. See ya.